This is code 2896. Apply operations to make two string equal. From the yesterday's contest, third problem. You are given two strings s1 and s2, both of length n and positive integer x. You can perform any operation on the s1 any number of times such that you choose two indexes I and j. Flip both si and sj with the cost of x. You choose index I such that flip si and si plus 1 and with the operation cost equal to 1. Now to return minimum cost needed to make s1 equal to s2 or return minus 1 if it is not possible. So you are given this two strings and why is it possible to make s1 to s2 first of all, and then how much cost is required. So at every time what you are doing in any operation, you are picking two indexes or let's say two elements, obviously not distinct, I mean non-distinct indexes, so two different indexes. Then you change their bits from 00 to 11 or 01 to 10, something like that. Make it opposite. So the number of zeros and ones is overall not changing. So first thing which you can choose, okay, it may change. It may change if you make double one to double zero, but the change is always even number. So the difference between like what can I say, the changes, the number of changes is not odd. That is what return minus one if it is odd, and return like if it is even, that is possible to make the change. Then you have to calculate the minimum cost to make the change. So first thing we calculated, okay, v is the size of the array which is the which will represent the changes, and if they are not equal then this push this index because there requires a change. If there is zero then we require one, something like that, and if there is one we require something like zero. So these are the changes which we have to do. If the number of changes is odd, you return minus one. Otherwise, like how do you do the change? One of the greedy approaches to just to take two elements and do the change, just to make these two different. How can you make one is the difference between them, which is by shifting one bit at, like you are going from like yeah changing flipping one from first point to the like next point, like adjacent bits you are shifting. So that is like type 2 operation for some time. Okay, so for some time will be one into like that much distance between the two things. And otherwise you can take like you can directly do an operation I and j, but that will take you cost x. So I thought like why not get minimum of d comma x. But it is interesting, bit interesting that it's not only like that. What we are doing is we are the greedy would not work. Why greedy would not work, let me tell you the reason for that. So if there is a difference, let's say this is the first point, let's say 1, there are some spaces, and then there is second point of difference, then there is third point of difference, there is some point 4. What greedily I'm taking is I'm just taking 1 with 2 and 3 with 4. This is like yeah no other way than this in greedy. So 1 2 will go each other and 3 4 will go each other. Now what's the issue in this, like if it is good if we are like doing the first second kind of operation, because there is no point of like taking 1 4 or 1 3, like no point of pairing one with either 3 or 4 other than 2, because this will incur a very much high cost. Like why do we go for that when because that will be basically a distance between yeah 1 and 4. So when you take a distance between 1 and 4, that is obviously greater than this thing, distance between 1 to plus 3 to 4, because then we are only taking a small part of it. Similarly 1 3 is also not good, but what can make it good, that 1 to 4 I don't have to take distance. I can take x and change 1 and 4. Now what it helps me, if 2 and 3 were closer, so now I can take 2 and 3 and just take not x but the distance between 2 and 3. That I cannot take in the first case. I will never take the distance between 2 and 3 because I need to pair 1 with 2 to minimize that thing, that yeah. So this was not a good approach. So I hope you got like why greedy would not work. Greedy always says that pair 1 with 2, 3 with 4, and so on, so on, so on. First element, second element, third element, fourth element, so on. But DP may, what you can do, you can pair yeah as you want, like because you can pair 1 and 4, okay, with the cost x. Then you can pay, you have ability to pay 2 and 3 with the cost that is difference between 2 and 3, which is 1. Okay, in case of if they are adjacent, so that can be good. So I'm going to write dp size z. Should I write z plus 1 or not, like yeah. Now how do you get the db? Basically I'm saying that okay, whenever I see a particular thing I have two options. One is to take a difference between these two. Okay, Let me show you with the recursive way first, which is the integer solve. You are present on id and you have a vector. That is the vector on which we are traversing. If id is equal to n, काम हो गया अपना. Okay. Now what you will need to do कि अभी करने का particular thing. You have two options. In option one, you take x into consideration. Okay. Or you take the difference into consideration between these 2 points, and you move to id plus 2. Like basically id and id plus 1 ka difference we are taking into consideration. So the difference would be v of id plus 1 minus v of id. This is the cost, plus solve of go to id plus 2 v. This is the option 1 for you. Option 2 for you is, okay, solve will move to just id plus 1 and v. You have not combined id plus 1 and id. Like you have not combined 1 with 2, something like that, like the next difference point. But what you have done, with something other. You don't know which other. But this is sure that, okay, these two takes goes in pair. So when I take this as a singleton, there would be one singleton left always. So then what I do x by 2. Why x by 2? Because I cannot do x over here. Okay, what if I did x? Then it will go on something, something, something. That something will have two options कि either to pair this and next one. That can be done कि 2 को 3 के साथ pair करना है या 2 को 4 के साथ pair करना है. If 2 को 4 के साथ pair करना है तो x by 2 plus id plus 1. Okay. Okay. Now you will see that, okay, so ये 2 को 4 के साथ pair कर रहा है. Yes. Then you are on 3. You have option that, okay, whether I take this thing, 3 does not know कि भाई पेयर हुआ है 4 और 2 पेयर हो चुका है. ये कंसिडर करेगा कि अगर ये दोनों का डिस्टेंस कम है तो वन ऑप्शन इज दिस फॉर मी, अदर ऑप्शन इज x by 2 लूँ और फिर आगे भेज दूँ. ओके. जब मैं ये ऑप्शन लेता हूँ, अभी तक मैंने ये ऑप्शन कहीं कंसिडर ही नहीं करा है, तो वो x by 2 x by 2 x by 2 चारों एलिमेंट पे हो जाएगा. एंड देन इट डज नॉट केयर कि तुम 1 3 को कर रहे हो 1 2 को कर रहे हो, बिकॉज उसमें तो ये केयर की बात ही नहीं है. और जब केयर की बात है तो हम केयर ऐसे ले रहे हैं कि हम दोनों को उड़ा रहे हैं एक साथ. एंड जब मैं बोल रहा हूँ कि 2 तुम 3 के साथ जा रहे हो, नेक्स्ट एलिमेंट के साथ जा रहे हो, एंड आई एम थिंकिंग देन तुम्हारा डिफरेंस जो है एडजेसेंट का, विच इज़ वेरी गुड. तो इट्स नॉट लाइक वेरी गुड in case of like greedy, but yeah, it can prove to be good. Like in case of 1 and 2, you don't know, so you go both ways. It can be good or cannot be good. So okay, but when I take this, तो मैं 2 और 3 दोनों को remove कर रहा हूँ, and I'm jumping on something other than this 3, so that कोई भी जो वहाँ से आ रहा होगा x by 2 लेके, वो 3 के साथ नहीं जाएगा, 3 के आगे जो भी उसके साथ जा सकता है. I think that got clear that why I'm doing x by 2 over here, and why it is like will definitely find the pair element. So अब 3 के बाद जंप करेगा तो कोई ना कोई pair element मिल ही जाएगा. 4 ये नहीं कह सकता कि मैं भाई ये करता हूँ कि id plus 1 id. So this के लिए ये condition should be true that, okay, minimum of this comma this. ये तभी हम सेकेंड ऑप्शन चूज कर सकते हैं id plus 1 आना, जब ये दोनों हो. और ये तो कर ही सकते हैं. Solve of 0 comma int x पैरामीटर should be passed और यहाँ पे पास है x equal to 0 मतलब kind of कुछ भी करना है इसको x ही कर दो and x equal to x e. Let's submit up 2896. Apply operation to make two string equal. We have not applied any DP. It's recursion but still looks fine. इसको float में convert कर दिया so that you get the integer values and answer. Basically x by 2 1 के केस में तो you know TLE आ रहा है तो एक पॉजिटिव साइन है कि DP हम लगा सकते हैं. लेंथ एक्चुअली कम थी 501. ठीक है तो ऐसे कर लेते हैं. सही है 100 100. Okay, guys, so that was about it. Question थोड़ा सा मतलब tricky था but straightforward था. Once you get that कि greedy would not work, कि greedy तक पहले पहुंचो कि okay, let me try to give this pair to this pair, this pair to this pair. Then prove yourself that okay, greedy maybe would not work. Maybe you can get a wrong answer there and then see the test case and then you saw oh, greedy would not work. So what can we do? There is an observation that कि 1 को मैं 4 के साथ भी pair कराऊँ तो cost तो x ही लगेगी. If I'm using the second operation, तो 2 को pair कराना 3 से, which is not case during greedy, but we can do that to minimize the cost and that's what we did. So DP लगा लिया और फिर how do you need to tackle that कि हर option point के बाद 2 option है कि या तो ये अगले आने वाले किसी के साथ ऐसे लेके उड़ेगा कि ग्रिड मतलब या एडजेसेंट की तरह उड़ेगा तो 1 into that, अदरवाइज ये x के थ्रू उड़ेगा और किसके साथ जाएगा वो नहीं पता, बट हाँ वो हमारा बन जाएगा. ठीक है, that's about it. Okay guys, bye.